This is problem number 5 for exam 3 review. So you're given these values and you want to know if this circuit operates as a linear amplifier or not. So the first step is to determine, is it in the active or the saturation region. So we know the drop here is 0.7, so this point is minus 14.3. IB goes through here, and IC up here. So IB can be determined by a 0 minus a minus 14.3 over the summation of the two, which is 14.3K. So IB is 1 milliamp. IC is beta times IB. So beta is 100, so this gives 100 milliamps. VO, which is VC, is 10 minus IC times 1K, so 100 milli times 1K, you're going to get minus 90 volts. This is way less than minus 14.3. So this is not active. So the next assumption is to assume that it's in saturation. So in the saturation conditions, you set the voltage here as 0.2 volts. And you're going to take a loop using that 0.2 volts and the 0.7 down here. So this will still be a minus 14.3 volts. Because that's still the same, IB remains the same as 1 milli. Now in this case, this is not correct to assume that IC is equal to beta IB. So IC now is no longer equal to beta IB. So to find IC, you can take a loop from the top to the bottom, plus 10 minus IC times 1K, and then the drop across here minus 0.2, and then a plus 15, and I can solve this for IC. So 24.8 milli. So VC is 10 minus IC times 1K, which is a minus 14.8, which is less than VB, which is minus 14.3. So it is saturated. And the thing that you want to check also in saturation is beta forced. Now because that relationship no longer holds of IC, where this beta is equal to 100. Now beta forced is going to be determined by the currents. So for IC was 24.8 milli divided by IB, which is 1 milli. So this was IC over IB of the saturation currents. That's the value of beta forced. And now beta force needs to be less than 100 to also be in saturation. So 24.8 is less than 100. And so my beta forced value is 24.8.